This is the brief on photonic AI processors. Based on Professor Dr. Guy Lakeman's research, we're exploring how swapping electricity for light in microchips is solving the massive energy and overheating crisis threatening the future of AI. AI is literally boiling our data centers right now, and light is the unexpected hero. So, let's dive into it. First, the heat problem. Traditional silicon AI chips use electrons, which generate massive heat, up to 1,000 watts per device. This requires huge, climate-damaging cooling systems. But photonic processors use light instead. They consume only about 30 watts, which is exactly the same as a human brain, and produce virtually zero on-chip heat. It's like comparing blazing, gas-guzzling furnaces to cool, ultra-efficient LEDs. Second, the mind-bending speed. These light chips are roughly 50 times faster than conventional NVIDIA GPUs because they use different colors of light to carry data simultaneously in the exact same space. Now, you might be wondering, wait, no way, it does math with just light? Yeah, absolutely. Instead of relying on billions of tiny on and off transistor switches, the chip uses the pure physics of light wave interference to solve complex equations instantly in one shot. Finally, the holographic memory leap. To feed data to these lightning-fast processors without bottlenecking the whole system, China is mass-producing 3D multidimensional holographic memory. Instead of storing data on flat 2D electronic surfaces, it uses overlapping light patterns to store data throughout the entire 3D physical volume of a material. It's basically the difference between writing on a flat piece of paper versus building a massive data-packed 3D crystal. Light-based processing and 3D holographic memory are completely rewriting the rules of technology, making the future of AI infinitely faster, cooler, and greener.